Hi guys, and welcome back to my channel and this new series that I call Journey to Med, where I'm trying my best and my very hardest to help prospective medical applicants achieve their dreams and their goals by getting into medical school. So if you've seen my 5 previous videos, something like that, I've done a video on each section of the UCAT where I explain to you guys how to prepare for them and walk you guys through some example questions. However, for the quantitative reasoning video, since quantitative reasoning is one of those sections that just has so many different question types, I wasn't really able to cover fully the different question types for quantitative reasoning. So I asked you guys if you wanted a part 2. Some of you guys said yes. So here is the part 2 for the quantitative reasoning video, where I will be walking you guys through some more quantitative reasoning questions. So, if this type of content interests you, please subscribe to my channel, like this video, and share this video with other UCAT test takers and other people that could benefit from it as well. Also, I wanted to say thank you to Medify for partnering with me in this video. And if you guys don't know what Medify is, who Medify is, this is the online question bank that I use and I talk about in every single UCAT video that I do. It's really the only resource that helped me achieve the score that I wanted to achieve and improve as much as I did during my UCAT journey. So if you guys want to check out Medify and maybe know a bit more about what it is, then you can always click on the links that I have left down below. And now that all of this is out of the way, let's get into the video. For each day is a table question, because table questions come up quite often in the UCAT, and this is kind of just a simple table question. It's not tax or anything. And the way that I kind of approach these types of questions is that I read the prompt here first, just to get kind of the rough context of what is this table about, basically. Then I read this part of the table and this part of the table. I really skim through just to see what type of things are inside. So these are numbers. So I just have a really rough idea of what the table is about. I'm not really trying to really understand it in its tiniest and smallest details, because that's not important and that's just going to make me waste some precious time. And then what I do is that I read the question, and then only at that point am I going to try to understand the table maybe a bit more to then answer the question. So let's do that. Let's read the prompt together. Okay, so the table below shows the valuation in $1 million, the total number of users in millions, and the number of daily active users in millions for different social media apps. So here we can see that there's all of the different social media apps that we all know about. And then they have the valuation, the total number of users, and then the number of daily active users. So yeah, and then it's just numbers inside. So I'm not going to be very wary of that. Just the only thing to remember is that it is in millions, so you have to remember that. Then let's read the question together. The question says, how many times greater is the valuation of Facebook than that of Snapchat? And the way to do this is rather simple. To know how many times greater is Facebook than of Snapchat, we just have to do a simple division. So at that point, I would use the calculator, the on-screen calculator. I would find the valuation of Facebook, which is 97,600, then million, there's million afterwards, but so 97,600. Then I'm going to divide that by the valuation of Snapchat, which is 6,340. 6,340. And that gives me a total of like 15.4 approximately. And the answer is here, which is 15.4. And then once I found that, I would just move on to the next question. Okay, so the next question that we have here is, what is the value per user of LinkedIn? And this question is rather straightforward. Again, you would use the calculator to answer it. And because you have the total valuation of LinkedIn here, 11,430, and you also have the total number of users of LinkedIn, the way to do this, you just have to divide the total valuation by the total number of users to figure out what is the value per user of LinkedIn. So let's do that. We have 11,430 divided by 429, which gives us 26.64, which is option 2, like B. Okay, so for the last question that we have in this set, yep, 3 out of 3, the question is, what is the mean number of active Instagram users per minute? And so if we look at the table, we see that we have here this number, 372, which is in the column that says the number of daily active users. So this basically means that every single day, Instagram has 372 million users every single day. So let's just write this down. So they have 372 million different users, and that's in one day. Okay. And a day is equal to 24 hours. Okay? But the thing is that the question asks us how many active users in Instagram are active every single minute. And the way to do this is we have to figure out first how many minutes are in 24 hours. So to do that, we do 24 times 60, which gives us 1,440. And then we just have to divide 3,072 million by 1,440 to figure out how many users are active every single minute. So now that we figured that out, let's just use the calculator and do our calculation. So 372 million, 3 divided by 1,440, which gives us this number here, and this number is this one. So that would be the one that we would be selecting. Okay, next. So that will, okay, let's mark the test to figure out if we got everything correct. And we got the 3 questions correct. Okay, so the next question that I have for you guys is kind of a question that's a bit weird, with there's kind of a diagram here. But the way I do this is kind of very similar to tables or graph questions. I just read the prompt quickly to understand what the diagram is about and how to understand and how to read this diagram. And then I just read the question and answer the question. So, okay, let's do this. George has had a fascination with toy trains since he was a very young boy. He is now embarking on a career as a toy train maker. Part of this business will be to design railway tracks. Below is one such design. The schematic, I don't know how you say that, includes the railway line, trees, so the non-quadrilaterals shown, so these are trees, and buildings, the quadrilaterals shown, so these are buildings. Now the question is, if the toy train model is scaled up to a normal size, the distance from A to B, so from A to B, is 210 meters, and it takes 24 minutes to travel between these 2 points. What is the speed of the train in kilometer per hour? So we need to figure out the speed of the train in kilometer per hour, right? But the information that they give us is in meters and in minutes. So the way that I'm going to do this to answer this question is I'm going to figure out first what is the speed of the train in meters per second. And then I'm just going to use the conversion that you probably know and that if you don't know, you should learn it. It's going to make you gain a lot of precious time in the UCAT because they love questions with speed and converting from meter per second to kilometer per hour. So what you do, and then at that point, would be to multiply what you have found in meters per second by 3.6. Okay? So let's do that. First, let's figure out what is the speed in with this information that we have here. So we have 210 meters, and then we have 24 minutes. So to figure out 24 minutes in seconds, we would do 24 times 60, which gives us 1,440 seconds. So, and then to figure out the speed, you have to do distance over time, and that gives you, so 210 divided by 1,440, and if you will use a calculator now to figure out what it is, so 210 divided by 1,440, and that gives us a speed of 0.146 meters per second. Okay? So that's in meters per second. And now to figure it out in kilometers per hour, we just have to multiply by 3.6. And so let's do that, times 3.6. And that gives me 0.52 kilometer per hour. Or 525. And that is this answer right here. Okay, the next question is, to make the toy model set, the building costs on average 1.53 pounds and trees cost on average 76 pence. How much does it cost for all the scenery in the above schematic, I'm not so sure how you pronounce this. Okay, so let's do this. We have 6 buildings at 1.53 pounds. So 1.53 times 6, 9.18. So let's write 9.18 on our sheet that we have. And then we do 0.76 times 3, 2.28. And then we add 9.18 to it, which gives us 11.46, which is this answer here. Okay, let's move on. The total distance from C to the end is 25 centimeters. 4 centimeters of which is spent under the tree. Track costs 23 pounds per centimeters. However, a special type of covered track is needed for tracks that run under a tree, and this costs 27 pounds per centimeter. How much does the track cost for the length that runs between C and the end? So this again, if you visualize it correctly, you see that from C to the end, there's 25 centimeters, okay? And then there's 4 centimeters that are spent under the tree. This means that the tracks that are used, based on what they tell us here in the question, have to be 2 different types of tracks. All of the tracks that are not under the tree are kind of normal, regular tracks, and the tracks that are under the tree are maybe more specialized tracks, let's say, that cost 4 pence more than the regular tracks. So to figure out how much this part of the track costs to what's his name, George, we have to use the calculator and figure out that we have 25 centimeters of track between C and the end, but 4 of these centimeters are spent under the tree. So we now have 21 centimeters that are regular tracks and 4 centimeters that are specialized tracks. Let's do this. Let's do 21 times 23. So that gives us 4.83 pounds, okay? And then we have the other 4 centimeters that are spent under the tree, and that is 0.27 times 4, which gives us 1.08, and then we add the 4.83 that we had just before, and that gives us 5.91 pounds for the whole track between C and the end, and that's the answer, option B. Next, we have the train makes a journey from start to finish, loading on bricks at each of the stations A to C. So at A, B, and C, the train will be loading bricks inside of it. It starts with 7 bricks, so at the start there's 7 bricks, and loads a certain amount of bricks at station A, okay? So we don't know how many bricks are loaded at station A. Then at station B, it loads half as many bricks as at station A, and at station C, it loads 6 times as many as station B. If there are 43 bricks at the end, how many bricks were loaded at station B? Okay, so for this, that's one of the questions, first of all, that are really tricky, kind of a game, could take a while to figure out, and that would be one of those questions that I would definitely, and if I were in the exam and under time pressure, maybe try for 20 seconds. If I couldn't figure it out quickly enough, I would then just do an educated guess and move on, because that's one of those questions that they're going to try and trap you and force you to try and really want to answer that question, and then you're just going to lose time and not answer all of the other questions that are easy towards the end. So at that point I would just skip, but for the purpose of this video, let's answer it together. So they say that we have, at the end of the journey, 43 bricks, right? But the train at the beginning had 7 bricks. So to figure out how many bricks were added to the train during the journey at station A, B, and C together, we have to subtract this, and that would give us 36 bricks, okay? So first, when you look at the answer options, we know that 36 is just not the answer. And if you would also do an educated guess, you could see that 36 is way out of kind of the spectrum and out of the scale of all of the other 4 answer options. So at that point, if you were doing an educated guess, never choose that answer option that's really far off from everybody else, because that's often, not all the time, but often wrong. Okay, so now they said that we don't know how many bricks were taken at station A. And then at station B, it loads half as many. So let's write an equation for this. And I think if you do an equation and you figured out the equation quickly enough, you would be able to get this question correct pretty quickly. So let's do this. So they say that let's note that X is the number of bricks that were added at station A. Then you would have to add, at station B, it loads half as many bricks as at station A. So you would have half of X, and that is, so that's at station A, and that's at station B. And then you would, at station C, you load it 6 times as many as B. So you would have half of X times 6. So that's at station C. Okay? And actually, half times 6, that's actually 6 divided by 2, so that's 3 x's here. That's equal to 3 x's. So our final equation that we have is x plus half an x plus 3x equals to 36. And so now we can just solve the equation and figure out what x is, what is x. So let's do this. So we have 4 and a half x's equals to 36. So that means that x equals to 36 divided by 4.5. Calculator, 36 divided by 4.5 equals to 8. So x is equal to 8, and then b is equal, so x here, that's the number of bricks that were loaded at station A. But station B here is half an x. So for at station B, we have to do half of x, which is equal to half of 8, which is equal to 4. And so the answer option is B. So the next question that I have for you guys today is a speed question where 2 different people are going along the same kind of circuit but at different speeds, and you have to answer a bunch of questions regarding them. And usually these, I remember that I've found this question pretty confusing each time it came up, and each time it came up with like different people or like different circuits. But once you figure out how to do it, it gets a bit more easy, and then you're able to really remember what are the steps to answering these questions and having them correct. So let's do this. So the thing that I do here is I read the prompt first, and then I just read the question and answer it. So let's do this. Sam and Manuel are standing at the same corner of a triangular racetrack. Each side of the track is 12 kilometers in length. After some time, they both start walking in the opposite direction. After, Sam walks at 4 kilometers per hour and Manuel walks at a speed of 6 kilometers per hour. So the first thing that I'm going to do here is that we are going to be drawing out the situation. So we have a triangle, equilateral triangle, where each side is 12 kilometers, okay? Then we have Samuel and Manuel. Let's say that they're both that are both at the same corner of the triangle here. And Sam, he walks at 4 kilometers per hour, and Manuel, he walks at 6 kilometers per hour. And then the question is, how much time will Manuel take to complete 1 2/3 of the rounds of the track in hours? So the thing that we have to figure out first is how many sides will Manuel have to walk to complete 1 2/3 rounds. So one round means that he's going to be walking 3 different sides. So this side, and this side. So he comes back to his initial position, which was here. And then 2/3 means that he would need to walk down 2 sides. So this side again and this side, and Manuel would end up here at the end of his 1 2/3 round. So that means if we count the number of lines that I put here, that he has 1, 2, 3, 4, 5 different sides that he walked against. And since each side is 12 kilometers in length, that means that he have to do 5 times 12, which is 50, 60, so 60 kilometers that he has to walk. However, we also know that Manuel's speed is of 6 kilometers per hour. And since we know all of the equations for distance, speed, and time, we know that time is equal to distance over speed, right? So let's do this. So distance is 60 divided by 6, so that would be 10 hours, and the answer here is this one. Okay, so the next question is, how long will it take Sam to complete 2 rounds in minutes? So really remember minutes, it's not in hours anymore, so at the end of the question, we will have to convert our answer to minutes. So 2 rounds for Sam, is this. So 1, 2, 3, that's 1 round, and then 1, 2, 3, that's another round. So he ends back up where he started, but he does 6, he goes down each side, a side of 12 kilometers 6 times. So we would have to do 6 times 12 to figure out. So that's 72. That's 72 kilometers in total that he's going to be walking around the track. And we know that his speed is of 4 kilometers per hour, okay? And so the way that we figure out how long is the same way as before. So the time is equal to the distance over the speed. So 72 divided by 4 will give us 18. And so that's 18 hours. And we want it in minutes. So to convert that into minutes, we would have to multiply it by 60. So 18 times 60 is equal to 1,080 minutes, which is option C. Next, both Sam and Manuel want to walk exactly 1 round. Since Manuel is a faster walker than Sam, he wants to give Sam a head start. So that they both finish walking 1 round at the same time. If Sam starts walking at 6 a.m., what time should Manuel start so they could finish at the same time? So, if we illustrate this, both of them want to walk 1 round. So they both want to walk around the round 1 time. So go and do 12 times 3, so that's 30 plus, so that's 36. 36 kilometers. They both want to walk 36 kilometers, okay? However, the problem is that Sam and Manuel, they have 2 different walking speeds. So to answer this question, I think the first thing to do is to figure out how much time it will take for Sam and how much time it will take for Manuel to walk around, to walk 36 kilometers. So let's do this. So for Samuel, we have time is equal to distance over speed, as we know, and then we do 36 divided by 4, which is Sam's speed, and that's 9. So that's 9 hours. Then for Manuel, we do the same calculation, distance over speed, 36 divided by 6, and that would give us 6 hours. And so they tell us that Sam starts walking at 6 a.m., what time should Manuel start so they can finish at the same time? So then we would just have to do 9 minus 6, which is equal to 3 hours, and if we do 6 a.m. plus 3 hours, because since Manuel is quicker and walks at a quicker pace than Samuel, he would have to start after Sam so that they both arrive at the back to where they started at the same time. So that would be 9 a.m. Another thing to be considerate at that point, if you were guessing or if you want to eliminate answer options, is that 3 hours is not an answer option. It's not correct because they want to tell you what time should manual start. So that should be in an AM, PM. It should be a time on the clock and not just a duration. So that would be wrong. Then you know here that Sam is faster. He walks quicker. Sam is slower than manual. So manual would have to start walking after Sam. And so 6 a.m. So 3 a.m. is wrong because that would mean that manual will arrive way, way, way earlier than Sam. 6 a.m. is also wrong because since they tell you here that they have the same, they have different walking speed, so they have to start at a different time to arrive at the exact same time at the end. And then you just have to figure out at that point, is it 3 a.m. or 10 a.m.? So with this question, actually, without even doing the question and without even doing any sort of calculation, you would already know that what you're looking for is either a 9 or a 10, because all of the rest of the answer options are incorrect, just based on the text. Okay, so the next question is, after 45 minutes, what percentage more distance would manual have covered than Sam? What percentage distance? So now what the indication that we have the time. We know that they both done 45 minutes, and 45 minutes is equal to 0.75 hours because it's 3/4 of an hour. And we want to know what percentage more distance would manual have covered than Sam. So at that point, we have to figure out the distance covered for both Sam and manual. So for Sam, the distance is equal to time times speed. So it's 0.75 times his speed, which is a 4, which is equal to 3. Okay, so he would have done 3 kilometers. And then for manual, the distance is equal to time times speed, which is equal to 0.75 times 6, which is equal to 4.5 kilometers. Okay, so now that we have both of these answers and we want to figure out what percentage more distance would manual have covered than Sam, if we look at this and we consider that 3 kilometers, which is what Sam has covered, is 100%. Okay, it's 100% of what Sam has covered. And we want to know how much more has manual covered than Sam. We actually can see that 4.5 is a combination of 3 plus 1.5, right? So 3 is the 100% of Sam. So that's what Sam has covered as well. So they both covered 100%. But manual has covered an extra 1.5 kilometers. And we have to figure out how much in this, what does this correspond to, in percentage. And we know that 1.5 is half of 3. So that would be 50% because half of 100 is 50. So manual has covered 50% more than what Sam has covered. And so that would be answer option C, I think. Okay, let's look at the answers for the last 4 because I was searching for the correct questions to answer to help you guys in the best way. So let's see. And the last 4 questions are correct. Okay, so I think I'm done answering the questions for today. I hope that this video was helpful, that you were able to learn a few tips, tricks, and techniques for quantitative reasoning. And if you enjoyed this video and you liked it, please subscribe to my channel, like this video, and share this video with other UCAT test takers that could benefit from it as well, because I'm here to help you and I hope that these videos are able to help you guys. So until next time, I think I'm done. Thank you for watching.